Hello everyone, this is performance patterns for the Ironman triathlon. First of all, this race consists of a 2.4-mile swim and a 112-mile bike ride, a 26.2-mile marathon, and all in all, it takes 17 hours maximum to complete the race, or otherwise you are stopped at that period. The race also consists of two transition points where the first one involves changing from wetsuit to cycling clothes, and the second one involves changing cycling to running clothes. Winners receive prizes that involve money, but at the same time, hobbyists or amateurs have this chance to prove if they have what they got to finish the race. For this analysis, a friend of mine has asked me to consider how he will perform on this competition, and for that, it is important to understand what are his daily habits. Does he eat Pop Tarts all day? Does he sleep late at Sundays? And also considering that he's not strong enough in swimming, biking, nor running, for which it is important for this analysis to understand which areas to focus, which are the variables that more correlate to winning the first place on the Ironman, and what are the probabilities of winning given certain conditions. The database for the performance analytics that was done was taken out from different web pages of Ironman that provided statistics of different years, of different regions, and of different cities. This is the competition from 2016 through 2020 of the Florida Ironman, and the idea here was to analyze this database, determine which are the strongest variables that will be able to predict overall rank, and also to focus not only on ranks but also on times made throughout the different competitions. In the same way, the analysis only took into consideration finishers and not for people that weren't able to finish the race, since our friend is interested in not necessarily on getting on the first place, but on finishing the race within the 17 hours. After to understand how these variables are correlated, the following matrix was performed, where we can see that the five highly correlated variables are the run rank against overall rank, bike and overall rank, swim rank and overall rank, run rank with bike rank, and bike rank with swim rank. It goes from 0.92 the highest to 0.68 the lowest. To better understand this relationship among the variables, we go from the lowest correlated variables that showed a positive correlation. And here we can see that as it has a 0.68 coefficient, the data points are still pretty much scattered among these plot. But as we continue and the correlation increases with the different variables, like here bike rank versus run rank, we see that the plot will be continue to look less scattered as we proceed. In swim rank versus overall rank, which are the variables that are going to interest us the most, the 0.72 correlation still shows that as these variables are correlated as such, we can have a more correlated variables that will explain a relationship towards getting a higher rank in the overall rank. This is a better example where we have bike rank versus overall rank signals a 0.91 correlation, or a very strong correlation that these two variables move in a positive direction. When one increases, the other one increases. Same here with run rank versus overall rank, even though the correlation coefficient increases from 0.91 to 0.92, you can still see a little difference on how the points continue to get close enough, signaling that they move more and more together in a same manner and in a positive way. To understand these correlations, since we know that correlation does not necessarily mean causation, a regression analysis was performed where an R-squared of 0.99 indicates that the three variables that we chose, which are swim rank, bike rank, and run rank, highly correlate to the expected outcome of an overall rank. So as these three move positive, also an overall rank will be positive, meaning that it will lead to a better position in the overall competition. This also gives us the equation, the equation of the line that will predict the overall rank for any competitor, and in this case for my friend, where we see that we take the numbers of the three variables or the slopes, We multiply it by the expected rank we would like to have, and also we add or we subtract in this case from the y-intercept. To also to further validate the how the model works, we also take a close look to the significance f, which is, as it is closest to zero, it is a better indicator that the model works good. And also the p-values of the coefficients we just mentioned, they are they have to be less than 0.05, and these numbers are p-values are at zero or are extremely low, which also means that these variables not only correlate each other, but that the independent variables may actually influence the outcome of the dependent variable, which in this case is the overall rank, and not other external factors that we are not necessarily taking into consideration. To also understand how well this line predicts an overall rank, because it is not professional to just plug in the numbers in the model and expect to have a 100% accurate predicted outcome. We have a residual analysis where we see that the predicted overall rank in the original this is the predicted overall rank, and the residual shows the difference between the original value and the predicted value. We can see that these residuals are still high out in through these first 15 records, and even though these variables show a strong correlation and a low p-value, this regression line has not been trained and optimized yet to for its better and most optimum performance, for which also a Bayesian analysis had to be performed to understand on which of the three areas it's more important to focus depending on the probabilities of winning given certain scenarios. In the first scenario, we have the swimming segment, where the first place, where the probability of being in the first overall rank, given that my friend finished first, or given that a person finished with the best time on swimming, is of 92.8. It is important to note that the probabilities for every year of the studied period were defined, and also then a weighted average of probabilities were determined as a unique probability for each scenario. This methodology was made along the three different segments and for the first, second, and third place. As you can see here, in the second place, the probabilities increases of being in the second place given that you had the most efficient time in swimming. In the third place, it's also of 96.2%, which continues to increase the probability of being in lower places. But at the same time, when we take a look to the next segment, which is biking, which, if you recall, these have coefficient value of zero, correlation coefficient of 0.91, we have that the probability of winning in first place, given that a person had the most efficient time in biking, is of 99.7%. We will see that getting in a second place with the same condition gives a 99.2%, and a third place gives a 99%, where it is signaling that the probabilities are lowering but are staying within the threshold of 99% to 100%, or in this case to 99.9% of probability. When we go to running, which is the highest correlated variable, that is of 0.92, 0.01 difference between running and biking, we have a probability of finishing in a first place, given that the person had a most efficient time, of 99.7%. As we go to the second place, the probability increases to a 99.8%. And finally, the third place gives us a 99.9%. With all these probabilities explained, I would like to take us back to the slide of the correlation matrix, where we see that we have chosen the first three variables. The first two of those three have a correlation coefficient of 0.91 and 0.92, and they have probabilities, given the scenarios that we mentioned, that stay within the threshold of 99% to 99.9%, while as the swim rank has a probability that will range from 96% to 98%, or even lower probabilities, but stay within that similar range, meaning that these values don't necessarily move in a positive direction as strong as a 0.9 coefficient will give, but moves in a positive direction with a coefficient of 0.72. For this, we understand that transition times are not as important for an amateur, because the most important here is to focus on the performance on the different segments, while top athletes or professional athletes will need to focus on transition times, since these little margins among probabilities highly depend on the minutes and on the seconds that of difference that a person will have during these transition times. For our friend, what I strongly recommend is to focus on the two highest correlated values, since they are similar in nature, 0.91 to 0.92. But moreover, focus on on the run segment. Continue to develop all the necessary qualities to be a good runner, and also consider purchasing this helmet, which is a low purchase in comparison to a new bike, since it will also lead in reduction of time while doing the bike segment. So as a final recommendation to my friend is, do not focus on transition times since you're not a professional or top athlete, but focus on the run segment, if it's really an objective to finish the race. With this said, thank you very much, and I hope this have been a really interesting patterns and recognition analysis. Thank you very much.